Okay guys, welcome back. So in this video I'll be talking about the periodic table. So in the last video I concluded by explaining you about the general concepts of general chemistry. So this is also another topic of general chemistry. So in this video I'll be talking about what is the periodic table, why is it important to make a periodic table, and what you can gain or what you can do with the periodic table, and the types of characteristics or the different characteristics that you can observe in the periodic table. So this is actually a series of videos as I have been doing for chemical bonds and the other concepts of chemistry. So in this video, first of all, I'll give you a brief introduction as to what a periodic table is. So what is the periodic table? So actually a periodic table is used to classify chemical elements. Now you know that there are various types of elements. Now for example, if you take sodium and magnesium, they may be somewhat similar, but their melting points and the boiling points may be different. However, both of them are classified as metals. But if you classify two metal and a non-metal, for example, if you take magnesium and carbon, how can you classify that? How can you classify, how can you distinguish the difference between the chemical and the physical differences between carbon and say oxygen, right? So you need some classification. Now you do various classifications in day-to-day activities. So for the same thing, for the same occasion for elements also, you need a classification. So we use the periodic table, the concept of periodic table, which is a general table, to classify these elements. Now various classifications have been presented over time. For example, various scientists used various types of periodic tables. For example, Newland, Lothar Meyer, various scientists use various classifications. There are many advantages and disadvantages, but that's about the history of the periodic table, and I will not mention you about the history of the periodic table because I am only focusing on this video only on the main chemical points or the main chemistry points of the periodic table. However, the most recognized and the most used and the most useful classification of the periodic table was presented by a scientist called Dmitry Mendeleev, right? He presented that in the late 1870s. So the modern periodic table uses classification based on the atomic numbers or the electronic configurations of elements. Now in the case of other scientists, various scientists, as I mentioned a little while ago, various scientists presented various periodic tables, and their basis of the periodic table depended on various factors. However, the modern periodic table, which was presented by Dmitry Mendeleev and was modified by various scientists, uses a classification or a basis of atomic numbers or the electronic configurations. Now I assume that you know about the electronic configuration by now, because I explained to you in one of my previous videos on the general concepts of general chemistry. So in this video I will be talking about how the periodic table is classified according to the electronic configuration. Now due to this electronic classification configuration, you know that now if you take two nonmetals, as I mentioned a little while ago, if you take carbon, you can say carbon has a configuration of 1s2, 2s2 and 2p2. However, oxygen has a configuration of 1s2, 2s2 and 2p4. So the only thing that differs carbon from oxygen is that oxygen has two more p subshells, two electrons filled to the 2p subshell, right? 2 electrons filled to the 2p subshell. So that's what differs oxygen from carbon. So due to these electronic configurations, there's actually a recurrence. Now for example, if you take carbon and silicon, right, or another one oxygen and sulfur, right, so they have recurring ones. Now for example, carbon has an electronic configuration of 1s2, 2s2 and 2p2, and silicon has an electronic configuration of 1s2, 2s2, 2p6, 3s2 and 3p2. So what happens is that now if you classify these 1s2 apart from this, carbon has 2s2 and 2p2, and if you classify 2p6 apart from this, silicon has 3s2, 3p2. So what actually happens is that when you compare carbon and silicon, you can see that in both carbon and silicon, in the last subshell or in the valence subshell, what happens is that there are two electrons filled to the p subshell, right? There are two p electrons, right, in summary. So we expect that the physical and the chemical, now they may change, right? For example, the melting point, the boiling point, and the other factors may change, but at least some of the physical or the chemical properties of carbon and silicon to be similar, right? So that is the use of this one. The recurrence of the chemical properties of elements is the prime advantage of this classification. Now, according to this classification produced or presented by Dmitry Mendeleev and modified by various scientists, we get a modern periodic table as follows. So this is the classification of periodic table I was talking about. Now, for example, as I mentioned here, you have carbon and silicon, one over the other, right, and germanium, right? So if you take all those, you will have a common electronic configuration. So that's the reason as to why they are classified one over the other. So you can take another example, oxygen and sulfur here, and sulfur and selenium, tellurium, polonium, and so on. So they have a similar electronic configuration. So that's the reason as to why they are classified one over the other like this, right? You can see all over here, right? So I'll explain you about these horizontal, these vertical lines and these horizontal lines in the second part of this video. So that's about the periodic table. So we'll discuss about the periodic table, the classifications, the differences of different elements, and the types that you can see, the distinguishes you can see in the periodic table as we go through this video and the next videos. So having explained about a general description and the introduction to periodic table, let me introduce you about the main characteristics of the modern periodic table. Now you can see here. So as I mentioned a little while ago, there are vertical lines like this, right? So if you calculate 1, 2, 3, 4 up to 18, right? Up to 18. Now there are, so before explaining that also, there are, when explaining about the vertical lines also, there are various classifications. Now I have not included this in this presentation, but what happens is that there are various classifications. Now you can see that there's a classification here 1, 2, 3, 4, 6 like that going up to 18. Another classification is 1, 1A, right? 2A, 3B, 4B, 5B up to 8A like that. And another classification is 11A, 2A, 3B, 4B, 5B like that. Now there are various types of classifications, but in this video I'll be talking about the American classification, right? So the American classification uses just the numbers from 1 to 18 for the vertical lines, right? 1 to 18. So that's the things here on top I'm talking about. 1, 2, 3, 4, 5 like that, 12, 13 like that up to 18 here. And we call these 1, actually now 1, 3, 11, you know, these are the atomic numbers. Now I'm not talking about the atomic numbers when I come to horizontal lines. So there are actually 7 rows, right, or horizontal lines, 1, 2, 3, 4, 5, 6, 7, right? So we call these 1, 2, 3, 4, 5, 6, 7. We call those by special names. So that's actually the main characteristic, right? So there are actually, for the periods we don't actually classify, but for the groups we classify these according to various classifications. So the classification that I'll be using here is the American or the most modern, right, classification. So although elements can be classified according to various methods, these classifications finally converge to 3 main categories. Those are the groups, periods, and the blocks. So what is a group? Now if you take the periodic table again, right, if you take that picture again, which I explained it here, you can see that, as I mentioned, there are vertical lines like this. So we call those vertical lines groups or families. Now you can see that hydrogen, lithium, sodium, potassium, rubidium, cesium, and francium, they come in one vertical line. So that's a one group or a family. So a similar thing can be seen here: beryllium, magnesium, calcium, strontium, barium, and radium, iron, right, osmium, and so on, boron, aluminium, gallium, indium, thallium, and so on. So actually now these terms UUT, UUQ, UUP, those are actually new terms, right? So they are not been actually 100% classified. So don't pay attention to those. Just pay attention to up to here, right? Up to this CN, right? To the 112th element. Now You can see that there are various vertical lines. So we call those the groups and the families. So there are 18 groups and 18 groups in the periodic table. So actually groups usually have more significant periodic trends than periods and blocks. So you will learn about that in another video when I talk about the various types of differences of elements, how we can classify, how we now. This is actually a simple classification. This is all classifications, as I mentioned here. All classifications converge to these three main categories. So these three main categories can in converse be diverged to various other classifications, right? Can diverge to various other classifications. So when we come to those classifications, you can see that you can observe that groups have more significant periodic trends than periods and blocks. Now, having explained about the groups, another important point about groups is that now there are various types of names, right? Various types of names when you come to groups. Now this is actually not very important, right? Just for general understanding, I am explaining you. So the first group is also called the alkaline metals, because we call those the alkaline because we found that in alkaline state. And the second one called alkaline earth metals, second group. And the last group, or the 18th group, is called the rare gases. Now you may see in some books that these are also called noble gases. Now although we call those noble gases or unreactive gases in particular, we don't now consider these to be unreactive, because what happens is that in the we have already found compounds containing argon and xenon. For example, you can find XeF6 or xenon hexafluoride, right? So there are various compounds have been formed of argon and xenon. So we no longer call them unreactive or noble gases, we call them rare gases. So one of the important characteristics of the 18th group, this is the 18th group, helium, neon, argon, krypton, xenon and radon, right? All these are gases. Now none of these groups or the vertical lines or the families have only gases. Now helium is a gas, but lithium is a solid, sodium is a solid, potassium is a solid, right? Now oxygen may be a gas, but sulfur is not a gas, right? Fluorine is a gas, chlorine is a gas, bromine is a gas, iodine is not a gas, and astatine is also not a gas. So 18th group is the only group that contains only gases, right? So that's also another important characteristics of the 18th group. Now having explained about the groups, let me explain you what are the periods. So as I mentioned a little while ago, in the periodic table we have the horizontal lines and the vertical lines. So the vertical lines were called groups or families, and we call the horizontal columns, horizontal rows, right, in fact, as the periods, right? So these are period. Now for example, this hydrogen and helium fall under the period 1. Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine and neon fall under period 2, and so on. Now these are periods. So any horizontal line in the periodic table is called a period. Now when I'm talking about the horizontal lines, don't pay attention to this, right? So I'll explain you about this concept in the concept of blocks and the D subshell filling. So this is actually a converge. You can see from here. Now if you come here, this is 54 xenon, 55 cesium, 56 barium and 72 hafnium, right? So what happens if from 57 to 71 is that this range of elements here, within this range, is diverged to a row like this, right? Diverged to a row like this. So what actually happens is that this whole row, now don't consider this to be a period, although this, you see this, now these are also horizontal rows. Now you may assume that this is also a horizontal row, so you should consider it as a period. But what happens is that now this from 57 to 71 is diverged like this, right? So this is another classification. I'll explain to you in the second part of this video. So don't consider these two rows, the lanthanide series and the actinide series, as two periods. These are just converges of this, the 6th and the 7th period, right? So that's the reason I explained here. The 6th and 7th periods are further diverged in the middle two group categories called the lanthanide series and the actinide series. So elements in similar periods and groups show metallistic relationships. Now for example, you can see here, now as I mentioned a little while ago, now oxygen and sulfur, or nitrogen and phosphorus, carbon and silica and germanium, they may have similar characteristics, but sometimes they may be different. They should be different, right? The melting points, the density, the boiling points, and the physical characteristics may differ. Even some chemical characteristics may differ, but there may be some characteristics that they share in common. So that's the reason as to why they are classified into one group. Similarly, when you are talking about a period also, there are various classifications, and you will learn under some difficult or hard theories of chemistry that, unlike as in the case of groups, elements in periods also have some similar chemical and physical characteristics. Not all, but maybe some, right? So the last type of main characterization, or the characteristic that you can see here, are the blocks, right? So blocks are another type of classification. So a block is actually based on the filling of electrons to electron shells. Now you know that if you take carbon, you can say carbon has an electronic configuration of 1s2, 2s2 and 2p2. So carbon falls somewhere here. So you can see that carbon is on the 14th group, right? So 14th group is here. So carbon is here, right? So when you think about carbon, so 1s2, 2s2 and 2p2, so the last electron, the last two electrons, right? So we actually pay attention to the last electron. We also call that the distinguishing electron. So that electron fills into the p shell, right? P shell. So actually to the 2p shell. So we call carbon to be in the p block. Now if you take another element, sodium here, right, it's in 3s and it should be 1 because its last configuration is 3s1. So sodium is here. So since the last electron, or the valence electron, or the distinguishing electron fills to the 3s electron shell in sodium, we classify sodium to be in the s block. Now if you take another element here, you can see here, take some iron, right? Iron or vanadium or somewhere, right? Now this is the D block. So if you take iron here, you can say the iron's configuration, or if you take for simple take scandium, right? Scandium. So the scandium's configuration is D1 and S2, right? S2. So S2 D1. So actually we consider, although the last electron fills inside, we consider the last electron to be filling into the D block, right? So we actually write the configuration based on that. So what happens when you look for iron or a scandium atom outside is that you see that the last electron may be filled for the 4s shell. What happens is that according to the rules, according to the Horn's rule and various other rules of electronic classification or electronic configuration, we consider that the last electron to be filled to the D block or the D electron shell. So we classified iron or scandium or any other material which fills D electrons last to be in the D block. And as I mentioned a little while ago, now here is 57 and here is 89 to 103. So this is the lanthanide series that diverges from 57 to 71 and 89 to 103. So these elements share a common characteristic, right? Some common characteristics, but we cannot classify them to as periods, but we classify them as blocks, right? So that's the difference between the period and a block, one of the differences. You can see that difference in the case of the lanthanide series and the actinide series. Now these divergence, now this is the lanthanide series, the 4f block, right? In the lanthanide series, the last electron fills to the 4f block, and in the actinide series, the last electron of all these elements fill into the 5f block. So we call those the 5f block, right? So this actually the f block is a divergence of the D block, right? So those are about the blocks and the groups. Now we can see that the classification, if you take, the S block varies from 1 to 2, the D block from 3 to 12, and the P block from 3 to 18, right? So you should actually remember this concept when you are taking about some questions or problems or quizzes or even assignments about the periodic table, right? So you can say that you can easily classify according to blocks, but you should remember about the groups and the periods, in fact, right? So Actually, in this video I explained to you about the periodic table, what is meant by the periodic table, what is a periodic table important, what are the modern types of periodic, what are the modern characteristics that you can find in the periodic table, and these characteristics in detail. So in the next video I'll be continuing about the topic of periodic table, but I'll be talking about various actually differences or characteristics or another classification or other things, physical and the chemical properties you can see in the elements in the periodic table. So thanks for watching this video and see you then.